Hello everyone, welcome back to my lesson. We're meeting again. So our today's lesson is about 2D, two-dimensional trigonometric 2D. Today we'll be focusing on question 4, and it's as follows. Without waste of time, let's indulge together. In the diagram below, which is 4.1, ABC, ACD, and ADE are right angle triangles. Now, if you are given a right angle triangle, there's two things that should come to your mind. Firstly, it's Pythagoras theorem. You think of Pythag, right? Number two, you think of trig ratios. So with trig ratios, you have your sine theta, which is equals to our opposite over hypotenuse. You have your cos theta, which is equals to our adjacent over hypotenuse. And then lastly, we have our tan theta, which is equals to adjacent over, sorry, not adjacent, but rather we can say opposite over adjacent, right? So when given a right angle triangle in trigonometry, you think of these two all the time. You think of these two. Unless maybe now you get to grade 11 where now they don't give you a right angle triangle. That's when now you start applying the sine rule, the cos rule, as well as the area rule. But we'll get to that level. Ne? So for now, we're focusing on grade 10. Uh, trig ratios. Ne? Or Pythagoras theorem. But it depends with the question, guys. It depends with the question. You cannot just guess and say, okay, I feel like I want to use Pythagoras theorem, or I feel like I want to use trig ratios. The question will direct you. So without waste of time, let's go to our question. Now they're saying BAE is equals to 90. So there's something that I've noticed here. A has a cap on top, which means A is equals to 90 degrees, which means A is equals to 90 degrees. But on which triangle? On triangle BAE. I hope it makes sense. Even A there on BEC has a cap, which means A is equals to 30 degrees on which triangle? Triangle BAC. Now we know how to read these two, ne? We know how to read. And then now they're saying BC is equals to 20 units and AD is equals to 60 units. That's not a problem. Now let's move to our question now. Let's jump to our question. Calculate the length of AC. That's the first question. We have to calculate the length of AC. But now, before you even calculate the length of AC, before you even calculate the length of AC, you need to specify which triangle you're working with. So in this case, I'm working with triangle ABC, right? I'm working with triangle ABC. Now, in triangle ABC, what happens now? Let's analyze together now. We are given your actual angle, which is 30, but that actual angle is opposite to this side BC, which makes it the opposite side. Ne? And then our 90-degree angle is opposite to this side, which makes it a hypotenuse. And then automatically this becomes our adjacent. So for right angle triangle, ne? For a right angle triangle, the angle, the side which is opposite to the actual angle becomes our opposite. And then the side which is opposite to our 90-degree angle becomes our hypotenuse. And then this will always be our adjacent because it's adjacent to this angle here, right? I believe that it makes sense. I believe it makes sense at this point. So now that we've labeled our sides, I think now we can try to connect everything to our trig ratios. So now we're looking for the trig ratio which will actually accommodate opposite and hypotenuse. We are given opposite, which is BC. We are looking for the hypotenuse. What is that trig ratio? There you go. You have your sine of 30 degrees is equals to our opposite side, that's 20, divided by our hypotenuse, which is AC, right? I still, I believe that we are still together. I believe that we are still together, my learners. So, at this point here, you can just simply cross multiply. You cross multiply, and then you end up with AC sine 30 equals to 20. And then now you apply your mathematical gymnastics, where you now divide everything by sine 30 to get rid of sine 30, and now make your what? AC the subject of the formula. I think we did the literal equations. Literal equations are about what? Getting a certain value, getting a certain variable as your subject of the formula. So AC now becomes 40 units. Now, which means now we have to go back to our diagram, and then now we write 40 there. Now, obviously, we have to write our 40. Now they are saying 4.1.2, calculate the size of CAD. Before you even calculate the size of CAD, you have to be able to read this. CAD, meaning they are looking for the angle of A because the cap is on top of A. But now on which triangle? Triangle CAD. This one. CAD. They are looking for this angle here. It's not a problem. It's not a problem. I've got your back. Don't worry, I've got your back. Right? So, how do we get that angle? Now, again, the first thing that we need to do, we have to analyze again. We have to analyze again. So now we are saying, okay, let me do this, let me do this, let me do this. In triangle CAD, we have to specify which triangle we are using. That's the first thing. We specify which triangle we are using. Yeah? So now in triangle CAD, this is 90. So this side is opposite to 90, which means this becomes our hypotenuse. And then this one here becomes our opposite because it's opposite to the actual angle. And then our 40 becomes your adjacent, right? I believe that now it makes sense now. It makes sense, ne? How to analyze our triangle and label our sides. And then from here, that's when now we can say, okay, we are given the adjacent and the hypotenuse, and we're looking for the angle. So which trig ratio will accommodate hypotenuse and the adjacent? That's a cos, ne? So it's cos what? Cos A. Cos A, but let's label it as cos CAD. Cos CAD is equals to our adjacent, that's 40, our hypotenuse, that's 60, right? And then from here, we can just say CAD is equals to shift cos 40 over 60, right? And then 40 over 60 would give us 48,19 degrees. But I know there's learners who will say, but Mr. Jocha, why are we having only two decimal, not one or three? It depends with the question, the instructions. So when you start your exam, there's instruction on the first page, right? If not the second page, they will give you the decimal. So say you have to round off to this decimal. So you have to make sure that you read the instructions. Make sure that you read the instructions. They will instruct you how to round off. Ne? So our CAT, that's 48,19. Now we got our CAD as 48,19, which means here you have 48. So now you have your what? Your 48,19. No problem. So now they are saying we should calculate the length of DE. The length of DE. But for DE, we don't have enough information, right? We don't have enough information. For an example, we don't have this angle here. At least if we can have the angle, then that's when now we can use the angle and the side, which is 60 there. So how do we get that angle? How do we get that angle? So again, it's not a problem. Because of this sign here, it implies that 30 plus 48 plus this angle is equals to 90. Because this means complementary. The angles, they add up to 90. So for that question there, that's when now we can say 4.1.333. This is 4.1.1, and then this is 4.1.2. So the point of departure here is to add all the angles, right? And look for the angle DAE. So how do we get DAE? So DAE is equals to 90 degrees minus 30 degrees plus 48,19 degrees. And then we get 11,81 degrees. So the angle here, you have your 11,81 degrees. Now that you have your angle there, 11, the side 60, now you can get the side of DE. So this side becomes our opposite because it's opposite to our actual angle. This one here becomes our hypotenuse. And then this one is our adjacent. So we're looking for the trig ratio that will accommodate adjacent and opposite. And that trig ratio is tan. So you have your tan 11,81 equals to what is our opposite? So we're looking for the opposite, which is DE. Opposite, that's DE. And then the adjacent, you have your 60 there, right? Now, this is not that difficult. You multiply by 60 both sides to get rid of that 60, right? And then we can say, therefore, DE is equals to 60 tan 11,81, which will end up giving us 12,55 units. So I've decided to use two decimal places. But remember, what did I say about the instructions? They will give you instructions on how to round off. Whether they can say round off to two decimal places or 3 decimal places, but they will make sure that they instruct you. So this is it, guys, for today. This is it, guys. I've decided to just explain this part of trigonometry, which is two-dimension. I hope we've enjoyed my video. After this video, I'll go to statistics now. I'll be explaining statistics, grade 10 statistics. But nonetheless, thank you so much for watching my video. Bye.